Hello everyone and welcome to my channel. In today's video, I am going to be walking you through how to build a Steam lobby in Unity using Mirror and FizzySteamworks. I'm going to start by creating a new Universal 3D project inside of the Unity Hub. I will be using Unity version 6000.0.44f1 if you would like to follow along exactly. However, this should work with other versions of Unity as well. Once you have the project open, let's start by clicking the Asset Store button on the top left, which will open the Unity Asset Store in your browser. Once you have it open, search for Mirror. The one you want should be the first result. Click on that one and then click on Add to My Assets. After it's been added to your assets, you should see another button that says Open in Unity. Click on that, then it will take you back to the Unity editor and open the Package Manager. From here, we can import the package into our project. Once you have successfully imported Mirror into the project, now you need to install the FizzySteamworks package. To do this, let's first open up a web browser and search for FizzySteamworks. The first result should be a GitHub repo. Click on that, then click Releases on the right-hand side, then click on the FizzySteamworks Unity package download link. I will also provide a link to this package in the video description. Back in Unity, click on Assets, Import Package, Custom Package, then select the Unity package that we just downloaded. Once you import the package, you will notice that there is a bunch of error messages. This is because we need one more package before we get started. Search in the web browser for Steamworks.net Unity package. Then click on the third result, which is another GitHub repo that contains the Unity package for Steamworks.net. Download the latest release, and then install the Unity package into your project just like we did with FizzySteamworks. Once again, I will also add this link to the video description. The errors should now be cleared from the console and we can begin creating the lobby. To start, head over to your hierarchy and create a new empty game object. This will be our network manager and I am going to name it Network Manager. Now I'm going to create a new folder under the scripts folder, let's call it Steam. Then inside the Steam folder, I'm going to right click, then choose Create and open the drop-down named Mirror. From here, we want to create a new Network Manager script. Let's call the script Custom Network Manager. Then I will create another script from the Mirror dropdown, but this time it should inherit from network behavior. I'm going to call this script Steam Lobby. Then we can start adding some components to our Network Manager game object. Let's start by adding the FizzySteamworks script, the Steam Manager script, and our newly created Custom Network Manager script. We also can add a network identity to the game object. Then in the inspector, find the transport attribute under Network Info, click on this, and attach the FizzySteamworks script. Now let's set up a basic UI. First, add a canvas. Then I am going to create two empty game objects underneath the canvas game object. I'm going to name these Main Panel and Lobby Panel. This will be used to switch between the main menu and the lobby. I'm also going to make a few edits in the inspector regarding their size. I'm going to make the background a solid color by clicking on the main camera in the hierarchy and switching from skybox to solid color. Then I am going to disable the Lobby Panel game object. Now I am going to create two scripts to manage the UI. The first script I will name Panel, and the next script I will name Panel Swapper. The whole point of this is to have a modular way to manage your UI screens as your game grows in size. Once you have created these scripts, go ahead and add the panel scripts to both the main panel and lobby panel. Then in the hierarchy, create a new game object called UI Manager and add the panel swapper script to it. After that, I will set up the skeleton UI with some basic text and then a button that says Host Lobby. I am going to speed up this part as you will want to customize the menu to match the look and feel of your game. However, if you are starting from scratch, feel free to copy what I am doing. Now we can finally start coding. Let's start with the panel script. First, we want to make sure to wrap our script inside of a namespace. I will be calling the namespace Steam Lobby Tutorial. However, you can name your namespace whatever you want. This will be important later on because if we have to make any modifications to the FizzySteamworks script, it cannot reference the default namespace. You will see what I mean later. For our panel script code, we can delete the default Unity code, then just add one public string variable. I'll call it panel name. Close out of the panel script, then open the panel swapper script. Again, start by wrapping this class in a namespace. This class will have one attribute called panels, which will be a list of panel objects. Then it will have one function called swap panel, which will take a string as an argument called panel name. What this function will do is simply loop through all the panel objects in the panels list and compare the panel name of the panel object to the panel name string argument. If the strings match, we'll set the game object to be active, otherwise we will set it to be inactive. Now click on the Host Lobby button in the hierarchy and scroll down in the inspector to find the onClick function. Click the plus sign and then drag in the UI Manager game object. From here, click on the No Function dropdown and select the panel swapper. From that dropdown, select the swap panel function, then simply type in the name you will give to your lobby panel. For my case, I will simply call it lobby panel. Lastly, we need to add the two panel objects to the panels list in the panel swapper. You can do this by clicking on the UI Manager game object, then selecting the panels dropdown in the inspector. Add two elements, then drag in the main panel and lobby panel game objects. Finally, make sure to go to the main panel and lobby panel, then add the panel names you want to use for them in the inspector. Now we will set up the lobby UI skeleton. I am going to do this by copying the text, then adding a play and go back button. I will also add an empty game object to store player names and ready up buttons once players join or leave. Once you have the skeleton set up, you need to make a prefab for the network manager to spawn in player names upon joining the lobby. To do this, start by creating an empty game object under the player's game object you created earlier, then add a button and a text object to it. Let's call this object player lobby slot. Once you have created this object, create a new folder under your assets folder called prefabs. Drag the player lobby slot object into the prefabs folder. Then let's also create a new folder under our scripts folder called handlers. Create a new network behavior script called player lobby handler, and then add it as a component to the player lobby slot game object, as well as a network identity. You can override the changes so it gets saved to the prefab. Then you may delete the player lobby slot from the hierarchy. Now, in the player lobby handler script, let's begin by adding a few variables and setting up a method skeleton. First, create a syncvar variable named isReady to keep the player's ready status synchronized across the network. Next, add a public button called readyButton and a text mesh prayugui object named nameText. Then create a method called onReadyStatusChanged with two bool parameters, old value and new value. After saving the script, go to the Unity inspector and assign the ready button and nameText fields to their corresponding UI elements. Alright, now let's build out the rest of the player lobby handler script. Inside the class, we already have our syncvar called isReady, the button for readying up, and the text mesh pro UI field for the player's name. Now, in the start method, we'll make the ready button only interactable if this is the local player. This helps prevent players from toggling readiness for others. Next, override onStartLocalPlayer. This will get called automatically by Mirror when the local player is initialized. Here, we enable the ready button and make sure isReady starts off as false. Then, in onStartClient, we make sure to register the player with a Lobby UI Manager instance. I'm going to comment this out for now until we implement it. Now let's add the method that handles actually changing the player's ready status. That's cmdSetReady, which is marked with the command attribute. This tells Mirror to run it on the server when a client calls it. In this method, we toggle the isReady value and manually invoke the onReady status changed hook to update the UI immediately. The onReady button clicked method just calls that command when the button is pressed. Simple enough. Then we define a helper function setSelectedButtonColor, which updates the button's colors depending on whether the player is ready or not. This is how we visually indicate the player's status. Finally, the onReady status changed hook reacts to changes in the isReady state. If we're on the server, we check whether all players are ready through the Lobby UI Manager. On both the client and server, we change the button color to green if the player is ready and back to white if they're not. Following this, we can start setting up the Lobby UI Manager. I'll create a new script under the UI folder and call it Lobby UI Manager. Now let's move over to the Lobby UI Manager script, which will act as the brains of our Lobby UI system. This script handles syncing the UI across all clients, managing player entries, and enabling the play button once everyone is ready. At the top, we bring in the usual suspects: Unity Engine, Mirror, TextMesh Pro, UI, and collections for a coroutine we'll be using later. We're wrapping this in the same namespace, Steam Lobby Tutorial, and then we define a singleton instance of the manager with public static Lobby UI Manager instance. This allows other scripts, like our player lobby handler, to access it directly without needing a reference passed around. Inside Awake, we make sure that only one instance of this manager exists. If another one tries to exist, we destroy it. This is a pretty standard singleton pattern in Unity. In Start, we disable the Play Game button by default. We only want this enabled when every player is ready, and we'll handle that logic shortly. Then we set up 3 public fields. Player List Parent. This is the parent transform that will hold the UI elements representing each player. Player Name Texts. A list that stores the text components showing each player's name. Player Lobby Handlers. A list that tracks each player's lobby script so we can check their ready status. And lastly, Play Game Button, the UI button that starts the game once everyone is ready. You'll notice that some of the methods like Update Player Lobby UI, Register Player, Check All Players Ready, and RPC Set Play Button Interactable are just method stubs right now. That's intentional. We're going to build out the rest of their logic after we've wired up the networking side of the Steam Lobby system. Also, take a look at Retry Update at the bottom. This coroutine waits for a second, then calls Update Player Lobby UI. This can be useful for cases where UI needs to refresh after some delay. We'll call this in situations where player data arrives a bit late due to network delay. Let's go back now to the Player Lobby Handler script and uncomment the Lobby UI Manager calls we commented out earlier. Then, in the hierarchy, we'll take the UI Manager object and attach the Lobby UI Manager we just created in the inspector, drag in the required player's game object and the play button game object to their respective variables, and then add a network identity component. Now for the Steam Lobby script. This script is where things really come together. It connects Unity, Mirror, and Steam into a fully working multiplayer lobby system. This script is a bit intense, so don't hesitate to pause the video and rewatch sections if you need to let something sink in. We start by declaring the Steam Lobby class and making it a singleton with public static Steam Lobby instance. This gives us easy access from anywhere in the project. We also declare a few key public variables: the host button, the current lobby ID, our network manager, and a panel swapper that handles changing the UI between panels. Then we prepare 4 Steam callback objects, one for when a lobby is created, one for join requests, one for entering a lobby, and one for detecting lobby chat updates. Inside the awake method, we implement a classic singleton pattern to ensure there's only one instance of Steam lobby. If another instance tries to initialize, it gets destroyed immediately. The start method handles initialization. First, it grabs the network manager component on this game object. Then it checks if Steam is properly initialized using Steam Manager initialized. If Steam isn't running, we log an error and stop the process. If everything's good, we activate the UI panel and register our callback handlers using callback.create method. These callbacks will fire automatically when Steam triggers lobby events like joining or creating a game. The host lobby function is pretty simple. It tells Steam to create a new lobby with a visibility of friends only, and it uses the max number of players defined in our mirror settings. This kicks off the Steam lobby creation flow. Then let's write all the callback stubs before coding them one by one. Once the lobby is created, onLobbyCreated gets called. If lobby creation failed, we log the error, but if it succeeded, we start the mirror host using network manager start host. Then we set a piece of lobby metadata called host address with the host's Steam ID. This is how we'll identify who to connect to later. Finally, we save the lobby ID so we can reference it in other parts of the script. Next is on-game lobby join requested, which is triggered when someone receives an invite to a lobby and accepts it. Before joining, we check if the client is already connected to another session. If so, we shut that down cleanly. Once everything is disconnected, we use Steam Matchmaking Join Lobby to request access to the new lobby. When we actually enter a lobby, onLobbyEntered is triggered. If we're already acting as the server, we ignore this. It means we're hosting, so we don't want to accidentally try to join another lobby. Otherwise, we pull the host's Steam ID from the lobby metadata using Steam Matchmaking Get Lobby Data, and we set that as our network address in Mirror. Then we start the client with networkmanager.startClient, and we switch the UI over to the lobby panel using our panel swapper. On lobby chat update is fired anytime someone joins or leaves the lobby or is kicked, banned, or disconnected. We first make sure the update applies to our current lobby, then we check what kind of change occurred using flags. If it's a meaningful update, we start a coroutine called delayed name update to refresh the player name UI after a short delay, and we also call check all players ready to see if everyone is ready to launch the game. Then the coroutine, delayed name update, waits half a second before calling lobby UI manager. Instance, update player lobby UI. This delay helps avoid bugs where player data hasn't synced quite yet, especially useful when someone joins the lobby and their name hasn't appeared in the list. Finally, leave lobby handles all the cleanup when a player leaves. We first gather the current lobby owner and a list of all members, then we leave the Steam lobby using Steam Matchmaking.leaveLobby and reset the lobby ID. Depending on whether we're the host or a client, we stop the appropriate part of the network. After that, we reactivate the menu UI and return to the main panel using panel swapper to swap panel, main panel. Back in the editor now, let's set the main panel active again and set the lobby panel inactive. Then add the Steam lobby script to the network manager object and attach the appropriate objects to their respective variables. Now that we've built out the core of our Steam lobby system, let's go back and flesh out the lobby UI manager script. First up is update player lobby UI, which is responsible for updating the player list every time someone joins, leaves, or changes their name. We start by clearing the player name texts and player lobby handlers list to ensure we don't carry over any outdated references. Then we grab the current lobby ID from our Steam lobby singleton and use Steam's matchmaking API to get the number of players in the lobby. To ensure the host always appears at the top of the player list, we fetch their Steam ID using the host address metadata from the lobby. We then build a new list of players, starting with the host and appending the rest afterward. If for some reason the lobby has 0 players, we log a warning and start a coroutine to retry the update after a short delay. After we've built our list of members in the correct order, we iterate through them and assign their names to the appropriate UI elements. We assume that each child under player list parent represents a player slot in the UI. From each child, we extract both the TextMesh Pro UI for the player name and the attached player lobby handler. We store both of these in their respective lists and update the player's display name by fetching it from Steam using Steam Friends, get friend persona name. Next is onPlayButton which is a simple but important method. This gets called when the host clicks the play button. We first check if we're the server using networkserver.active. If so, we use Mirror's server change scene method to load into the gameplay scene. This change will propagate to all connected clients automatically. The register player method is called whenever a new player object is spawned and wants to register with the UI. We parent that player's game object under player list parent to keep the lobby layout organized, and then we call update player lobby UI to refresh the list with the new player included. Now let's look at the heart of the ready check system. Check all players ready. This method runs only on the server and loops through all the registered players. If any of them are not ready, we disable the play button across all clients using a client RPC called RPC setPlayButton interactable, passing in false. If everyone is ready, we call the same method but pass in true, which enables the play button and allows the host to start the game. Finally, RPC setPlayButton interactable runs on all connected clients and simply updates the state of the play button based on the value passed in. This ensures that only the host can click the play button, and only when all players are marked as ready. Now we just have to stitch it together. Let's do this by first dragging the player lobby slot prefab into the player prefab slot on the custom network manager. Then on the host lobby button, add another onClick function, and then drag in the network manager into the game object slot. Then click on the drop down, click on Steam lobby, and assign the host lobby function. After that, under the lobby panel, click on the go back button object and add another onClick function. Drag in the network manager object again, then assign the Steam lobby leave lobby function. Lastly, open up the player lobby slot prefab and click the ready button game object. Add another onClick function by dragging in the player lobby slot object, then assign the onReady button clicked function. Now if we click play, you can see the functionality starting to come together. I can host a lobby and it displays my Steam name. I can ready up and unready at my discretion and then leave and rehost as needed. If you notice an error right after clicking host lobby, make sure that you have logged into Steam on your PC before clicking play. Before we can properly test our game's network functionality, we need to take a step we probably should have done earlier. Setting up source control. I'm going to assume you already have a GitHub account and Git installed on your local machine. Here's what I'll do next. I'll create a new GitHub repository and push our current Unity project to it. To do this, I'll start by creating the repo on GitHub. Then I'll grab a proper .gitignore file by searching for unity.gitignore in a web browser. Once I've copied that text, I'll navigate to the local directory where our project lives and paste it into a new .gitignore file. After that, I'll open a command prompt and run the git commands provided by GitHub to initialize the repo and push our code. Feel free to pause the video if you want to follow along with the exact commands I'm using. And don't worry if you see warnings about line endings when adding files. Those are totally normal and nothing to stress over. Once the repository is set up and your project is pushed, you'll need either a second computer or a virtual machine with Unity and Steam installed. On that second system, clone the repository, open the project in a separate Unity editor, and log in with a different Steam account. Unfortunately, I'm not aware of a reliable way to test multiplayer with two Steam instances on the same operating system, so this setup is a bit time-consuming, but it works, and it gives us a proper test environment for our multiplayer functionality. Once you have cloned the repository on another machine and opened the project in Unity, you can now start a lobby and then invite the other account through Steam. Your other account can now join and then you can both ready up. Congrats! We are almost there. Now we just have to make the play button work and spawn the players into the gameplay scene. To kick off this final part, we'll start by creating a new scene. I'm going to name it Gameplay Scene. Once that's created, I'll double click to open it. Then we need to make sure Unity knows about it by adding it to the build list. To do that, go to File, Build Profiles, and click Add Open Scenes to include it in the build profile. Then let's create a very simple player prefab to show proof of concept. I'll do this by adding a capsule object to the hierarchy, and then I will name it Player. From here, I will want to build a new network behavior script and call it Player Movement Handler. Inside Player Movement Handler, we're going to write a super simple script that gives each player basic movement controls, just enough to verify that networking is working properly. After we delete the starting network behavior code and put the class in our namespace, we just need the update function where we wrap our movement logic in an if is local player check. This ensures that only the player controlling this game object can move it. Without this check, every instance of the player across all clients would try to run this code, and that would break everything. You'd see jittery movement or complete chaos. Next, we grab input from Unity's input manager using input get axis horizontal and input get axis vertical. These correspond to WASD or arrow keys by default. We store those values in H and V and then create a new vector 3 called player movement. We multiply the input by 0.25 to slow the movement down to something more testable. Otherwise, the movement would be instant and hard to follow. Finally, we update the player's position by adding player movement to transform.position. Now in the editor, let's attach the player movement handler script to our player game object. After that, add a network identity component to the same game object. Once that's done, save your changes, then drag the player game object into the prefabs folder to create a prefab. After you've created the prefab, you can safely delete the player from the scene. Then let's go back to our lobby scene where we can populate the spawnable prefabs list with our player object. Then open our custom network manager script. Inside of our custom network manager script, we are going to add a new public game object variable called player gameplay prefab. This will serve as a reference to the player for when we switch from the lobby to the gameplay scene. Next, locate the overridden function called server change scene. This is a built-in callback from Mirror that runs automatically whenever the server changes scenes. Inside this function, we'll add a few lines of code to check if the new scene being loaded is the gameplay scene. If it is, we'll assign our player gameplay prefab to the player prefab field on the network manager. We'll also update the online scene property to match the new scene name. This ensures that Mirror knows which scene is currently active and which player prefab to spawn when the scene loads. Now click on the play button under the lobby panel in the hierarchy and attach the UI manager to the onClick function. Then select Lobby UI Manager and assign onPlay button clicked. Drag in the player prefab into the player gameplay prefab field on the network manager. Then click play and host a lobby. When you click ready up and click play game, you should see the player spawn in and you can move it around. Add, commit, and push the changes to GitHub. Then pull the changes on your other machine and host another lobby. Let's see what happens right now if we add another player to the game. At this point, you'll notice that you can see your own character move, but you can't see the movement of other players. So what's going on? The reason you can't see other players move is because their position isn't being synchronized across the network. To fix this, we need to add a network transform reliable component to the player prefab. This component takes care of syncing position, rotation, and scale between clients and the server. By using the reliable version, we ensure that updates are delivered more consistently, which is great for simple movement like ours. Once it's added, save the prefab and push the changes up to GitHub and pull from your other machine again. Now when you run the game with multiple players, you'll be able to see each other move in real time. And that's it! You now have a fully functional Steam integrated multiplayer lobby system built with Mirror and Unity. We set up ready states, synced player names and UI, handled lobby creation and joining through Steam, and even transitioned into a gameplay scene where players can move and see each other in real time. If you've followed along this far, awesome work. This is no small feat, and you've laid the foundation for building out a full online multiplayer game. From here, you can expand with whatever your co-op game needs. If you found this helpful, feel free to drop a like or comment with what you'd like to see next. And don't forget to subscribe so you don't miss future tutorials. Thanks for watching, and I'll see you in the next one.